In this part of the lesson, we'll be practicing questions on polygons involving some of the following types. For example, we need to apply the formula to find the sum of interior angles and probably use it to find unknown angles of a polygon. Or we need to apply the formula to find the interior angle of a regular polygon. And maybe we apply the interior and exterior angle formula to use it to find the number of sides of a polygon, and also need to decide whether is a polygon a regular polygon. Now, before we begin, some of the important concepts or whichever or formulas that we probably need to know. Number one, sum of all the exterior angles of any polygon is 360. It's by the property angles at a point. But the formula for the sum of interior angles of polygon will now be the formula n minus 2 times 180 degrees, okay, where n is the number of sides. And next concept, we know that the exterior angle of one regular polygon, since the total exterior angle is 360, so one of the regular polygon, one of the exterior angle will now be 360 degrees divided by n. Then what about the interior angle of a regular polygon? If it's a regular polygon, meaning all the sides, the angles are the same. So since I know the formula for the sum is n minus 2 times 180 degrees, I just need to take this divided by n, the number of sides. The third concept is, given a polygon, if this is the interior angle of a polygon, okay, what is the relationship between the interior angle and the exterior angle? The interior angle and the exterior angle of a polygon, this one over here, will be the exterior angle of the polygon. So the interior angle of a polygon add up to the exterior angle of a polygon will give you 180 degrees. They are angles on a straight line. So now we have these three formulas. We shall try to use them to solve the equations. Next question. Okay, given this picture over here, now what we are going to do is I have this following pentagon. Okay, pentagon, we have a pentagon, right, with its interior angles labeled. They will want us to find the values for x. Before we work out all the different types of solve the question itself, let us revise on the different names. If I have a three-sided polygon, it will be called a triangle. Okay, four-sided polygon is called a quadrilateral. Five-sided polygon, that will be a pentagon. Six-sided will be a hexagon. Seven-sided is called a heptagon. Eight-sided is an octagon. Nine-sided will be a nonagon. And 10-sided will be a decagon. And for the other remaining sides or different types, that will be called n-gon. For example, 12 sides will be a 12gon. Okay, so in this case, the diagram shows a pentagon. So in this case, the word pentagon tells you that the number of sides is 5. So it's a 5-sided figure. And we are looking at the interior angles. So what we need to do is we need to find the sum of the interior angles for a pentagon. The sum of the interior angles is given by the formula n minus 2, in this case n is 5, minus 2 times 180. Okay, do not divide by n. I'm not looking for one particular angle. I'm looking for the total angle. So that will give me 540 degrees. After which I know that, oh, the total of all these angles here will give me 540. So I'll have the angle 80 plus 40, 3x minus 35 plus x plus 2x equals to a total of 540 degrees. Now when we have working, we do not need to write the units. So now let's try to solve this question. Taking in the number of units, we have 7x. 7x plus the total will be 80 plus 40 minus 35. That gives me 85 degree to be equals to 540. So 7x will be equals to, we bring this over to the other side, so this one will now become a minus. So 540 minus 85, that gives me 455. And now I only want x units, I don't want 7 units, so I take 455 divided by 7, that will give me value 65. So hence the angle x will be 65 degrees. Okay. Next one, how do we make use of the interior angle formula for a regular polygon? For example, looking at this type of question, they tell you that ABCDE is a regular pentagon. First one, we know pentagon means n equals to 5, 5-sided. It being a regular pentagon, meaning that all the sides have equal length, all the interior angles are equal to each other. Okay, so in this case, if they want me to find angle ABE, I should start with finding one angle first, one interior angle. Probably I'll try to find interior angle EAB. Alright, so one angle, one interior angle will now be given by n minus 2, the n is 5, times 180. We notice that this is a regular polygon, so we divide it by 5 sides, and that will give us the value 108 degrees. So this angle is now 108 degrees. How are we going to use that to find the angle ABE? Well, we know that this is now an isosceles triangle because it's a regular pentagon. So therefore, angle ABE will be given by taking angle sum of triangle 180 degrees minus 108, the angle, divide by 2. That gives you the base angles of the isosceles triangle. And each angle is 36 degrees. So this one is angle sum of polygon. Of triangle in this case. Alright, so this is a very simple question on how we are going to use the interior angle formula. Let's look at the next question. Another similar question. Find the angle x between the two regular polygons. They mentioned to you that this is a regular polygon, so but they never tell you how many sides they are. So we have our first one over here, 1, 2, 3, 4, 5. All the sides are equal. So this is a 5-sided polygon. So down here we have the first one, n equals to 5, and probably I want to find one of the angle. Okay, one of the interior angle for this case will be 5 minus 2 times 180 divided by 5. And that gives me 108 degrees. So this angle is 108 degrees. Next, we have the other side. 1, 2, 3, 4, 5, 6, 7, 8. This is an 8-sided polygon. So this is actually a octagon. So to find the interior angle of that side of one polygon, that will be 8 minus 2 times 180 divided by 8. And that gives me an angle of 135 degrees. And since we have angles at a point, right, to add up to every angle to add up to 360, so we know that angle x is equals to 360 degrees minus 135 minus 108. And that gives me an angle of 117 degrees. This is angles at a point. So we have found x successfully. Okay. Next one, let's look at the next polygon over here. This diagram shows a triangle CXC inside a regular decagon. What is a decagon? How many sides are there? Well, a decagon has n equals to the number of sides, decade, 10 years, so a decagon is 10. Okay, but something to take note, x lies on the line CH, but did they tell you where is the center of this polygon? Is x the center of the polygon? Well, first thing to take note, this x is not the center. Okay, so please do not assume like XC and XZ are isosceles triangle, because it's not the center, it's not the radius, so it's not an isosceles triangle. Okay, and what else do they give me? You know that this is a decagon, and you have one line over here, CH, that cuts across, and this splits this decagon into exactly 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 into 5 sides each. So this line CH is actually a line of symmetry. In this case, so this is what we observe, and we know that I have the angle, this angle here is 27, and the angle over here is x. Okay, they want me to calculate x, so probably if I want to calculate x, that tells me that I have the angle 27. I want to find x, I probably need the angle XCD over here. But what do I know? I know that this CH is a line of symmetry, so it actually cuts the interior angle BCD into two equal parts. So our objective now will be to find the interior angle of the polygon, interior angle, and this angle is angle BCD. And we have a decagon, so it's 10 minus 2 times 180 divided by 10 sides. And that gives me the angle 144 degrees. Knowing that this whole angle is 144 degrees, and I know CH is a line of symmetry, I can get the angle XCD to be 144 divided by 2, which is 72 degrees. Now I know that this angle is 72 degrees. I can happily use the angle sum of triangles to find x. So 180 degrees minus 27 degrees minus 72 will give me the value for x. So 180 minus 27 minus 72, and that gives me 81 degrees. Have you gotten the answer? So the thing to take note, do not make any assumptions that x is a center. Do not assume that this is a isosceles triangle. And next, also look at the diagram, observe, and you can see that CH is actually a line of symmetry. Alright? Okay, we shall move on to the next question. Next type of question over here is, for example, if I were to give you a certain information, either the exterior angle or the interior angle of a regular polygon, and to use it to find the number of sides. Right? So down here, what do we have? We have the interior angle of a regular polygon is given to be 165 degrees. Now they want us to find the number of sides. Now there is actually two different methods that we can use. Method number one, okay, we are going to use the interior angle itself, the formula. The formula for interior angle is given by n minus 2 times 180 divided by n to be equals to the interior angle that is given to me, the formula, the number 165. Okay, using this, what I can do, you notice that this is a fraction over here. We can cross multiply our fraction. Okay, we can cross multiply the fraction itself, and we'll notice, and we need to expand this 180 inside here. So expand this, we'll get 180n minus 360 equals to 165n. Rearranging our terms and n over to one side, we will have 180n subtract. This one comes over here, so change in sign. 165n equals to 360. Okay, while this goes over to this side. Then now simplifying this, 180 minus 165 gives me 15n is 360 degrees, and will be 360 divided by 15, 24 sides. Well, this method involves a little bit of algebra, and you need to be careful in your calculations. Alternatively, you can also use method number 2. Method 2 is that we are going to use the exterior angle of a polygon. The sum of exterior angle is equals to 360 degrees. And we know that the interior angle plus an exterior angle equals to 180 degrees. So if I know the interior angle is 165 degrees, I will be able to find my exterior angle to be 180 minus 165. And that gives me 15 degrees. Since the total angle of the total exterior angle of polygon is 360, then the number of sides is simply taking 360 divided by 15. And that will still give me 24 sides. Now, which method do you prefer? The more algebra method or the exterior angle of a polygon? Okay, so you may use the different methods to find your answer. Coming up, next question, we are going to look at question number 6 over here. This diagram shows a regular n-sided polygon ABCDE, okay, regular, and it's given that triangle ABC is congruent. Right? First thing about regular, we know that the interior angles are going to be the same. So this interior angle and this interior angle are all the same. Right? So all these are interior angles. And we know that triangle ABC is congruent to triangle CDE. That means we have a couple of different same sides and same angle. We already know AB and AC are equal due to the fact that it's a regular polygon, and if that is congruent, that means the side AC and the side CE are actually equals to each other. Alright, because they are congruent, so the sides have the equal length. So in this case, you can see that triangle ACE is actually a isosceles triangle. Now, given that the angle ABC is 160 degrees, so 160, first one, find the value for n. Oh, what's the value for n? N is the number of sides. Again, given the interior angle, we can use two different methods to find the number of sides. Right? I shall just quickly do. Method number 1, using the interior angle formula, n minus 2 times 180 over n to be equals to 160. Or method 2, using the interior angle is 160. The exterior angle will be 180 minus 160. That gives you 20 degrees. And number of sides will be 360 divided by 20 to give me 18 sides. Or I can do method 1 where I cross multiply, rearrange, and find the number of sides. So therefore, the value of n is 18 sides. So this is the angle part B. Next one, find the angle of BCA. Where is angle BCA? Oh, BCA is the angle over here. This small angle. Well, this is a base angle of isosceles triangle. We already know that this is 160. So now we can happily find the base angle of the isosceles triangle. So for part 2, the angle BCA will be 180 minus the angle 160 divided by 2 base angles of isosceles triangle. And that will give me 10 degrees. Alright. Knowing that this is 10 degrees, we know this is also 10 degrees. Okay, so because it's congruent on both sides, right? This is also 10. This is also 10. Right? Now they ask me to find angle DEA. So I know that this small angle here is 10 degrees already. What I need to do, I'll probably need to find the angle CEA. How do we find angle CEA? I know that the blue triangle ACE is an isosceles triangle, right? That means I need to find the remaining yellow color angle over here. The whole angle is a polygon, regular polygon itself. It was 160, and we have this part to be 10. This part to be 10. The whole angle is 160. So we know that the angle ACE will now be taking the whole interior angle, subtract away the two small isosceles base angles of isosceles triangle, and we have the angle to be 140 degrees. So now if we know this is 140 degrees, we can use it to find angle CEA. Okay, so angle CEA, this one here is angle sum of triangle. Angle CEA will be 180 degrees minus 140 divided by 2 base angles of isosceles triangle. And that gives me 20 degrees. So now I know that this is 20 degrees. I want to find angle DEA. That will be 10 plus 20. So angle DEA will give me 10 plus 20 degrees. Have you gotten the answer? Alright. Let's continue to the last few questions. Now, what happens if I have a question over here? This diagram here is made up of 3 regular polygons. Okay, it's given to be 3 regular polygons, meaning all the angles are the same. And you can see that all these angles over here, they form up angles at a point, right? So I have A, B, and C joined together. A have 12 sides. So over here, n is equals to 12. What can we find? B has 4 sides. So n is equals to 4. Well, this is a regular quadrilateral. So that means this angle is straight away 90 degrees over here. And they want me to calculate the number of sides for shape C. But let's look for more information here. Now I know that this angle over here, it belongs to A, which has a number of sides, 12 sides. So from here we know that the interior angle, one interior angle, will be equals to 12 minus 2 times 180 divided by 12, the formula. And one angle is found to be 150 degrees. So this angle over here, 150 degrees. Now I already know that this is 90 degrees right angle. Okay, therefore I can use angles at a point to find the interior angle over here for polygon C. So interior angle of polygon C will be taking angles at a point 360 minus 90 minus 150 to be 120 degrees. Right? So since I know that this is 120 degrees, I need to find the number of sides. The objective in this case is to find n, the number of sides. How can we do that? We have the interior angle found, so there are two methods, method 1 and method 2. Method 1 using the interior angle formula where n is the number of sides that we want to find and equates to the interior angle that we have found, right? Then method number 2, the interior angle is 120, so the exterior angle will be equals to 180 minus 120. That gives me 60 degrees. Then the number of sides will be 6 sides, right? Hexagon. Or we can do method 1 where we cross multiply, expand and simplify. Shift the terms around. Solve for the value for n. Right, so both of us will get the answer n equals to 6 sides. Okay, so this type of questions is quite commonly repeated in the O levels itself, so it's something that you definitely need to know. Right, now let's move on to the next question. Given this question over here, a student constructs the following diagram and claims that this is made up of a regular pentagon. Okay, claims that this is true. Claim way, so don't know whether it's true or not. You need to check. Made up of a regular pentagon. Do you recall a pentagon has how many sides? So a pentagon has 5 sides, a square, and a part of a n-sided regular polygon. That's what they say. Okay, determine whether if the student's claim is correct with the necessary calculations. So what we are going to do, we are going to find out more things. Okay, the number of sides, for example, what is this n, and whether is it really true that this is a regular polygon or not. Alright, so 2 objectives. Number 1, what is n? Number 2, is it really a regular polygon? Okay, let's check. Now, using the information that we have, first one, we know that this is a square. So we have 90 degrees over here. So this is already done, 90 degrees. Okay, next one, we know that this is a pentagon. So if this is a pentagon, n is equals to 5. So we are going to find the interior angle of a pentagon. That will be 5 minus 2 times 180 divided by 5 to be the number 108 degrees. So showing that this angle is 108. Now what we need to do, we need to find what is this interior angle first. Alright, so we're going to find the interior angle over here. So this interior angle will be made up of angles at a point. Okay, so 360 degrees minus 90 minus 108. And that gives me 162 degrees, right? So now I know 162 degrees. These are the information that I have. What can I find? 2 objectives. Number 1, what is the value for n? So objective is to find n. and then explain whether is it really a regular polygon. Right, let's check. Right, first one over here, let's find what is n. There are two different methods. Method number one, oops, my handwriting. Right, that will be using the interior angle formula times 180 divided by n to give me 162 degrees. Or method number two, I'm going to use the exterior angle of the triangle. The interior angle is equals to 162 degrees, so the exterior angle is equals to 180 minus 162, which gives me 18 degrees. And number of sides will be 360 divided by 18. That gives me 20 sides. Right, similarly over here, we will have 180, right, shifting the terms around and subtracting them, we'll get 18n to be 360 and n to be 20 sides. So first we have found n to be 20 sides, right? Second thing to determine, so how do I determine whether is the claim correct or not? So they say she claims that this is a regular polygon. So we need to do an explanation. Is this really a regular polygon? Well, since the number of sides, since n equals to the number 20, is an integer. Alright, there is really such a polygon with 20 sides. If I have, for example, 21.5, then that's not an integer, right? So then can I have a regular polygon with 21.5 sides? That's not possible. So in this case, if I have a number where n is not an integer, then it will not be a regular polygon. So since this is an integer, right? So therefore, polygon is a regular polygon in this case. So therefore, the claim is true. Alright, have you gotten the answer? So things to take note. Number one, using the whatever information that's given to you, maybe find the interior angle or the exterior angle if you can, and use the interior angle or the information given to find the number of sides. Then we determine whether is it really a regular polygon. If it's a regular polygon, the number of sides will be an integer. Right? If it's not a regular polygon, the number of sides n that you have found will not be an integer value. Okay, with this, let's proceed to our last question. Something similar, but in this case, there is no diagram at all. You need to read the question very carefully and form the equation or form information to help you solve your problem. Right? Let's take a look. May claims that she can form a regular n-sided polygon. So we have two objectives. What is n? And really, is it regular? Okay. Now they want to tell me that form a regular n-sided polygon whose interior angle. What is the interior angle formula for one regular polygon? The interior angle is given by n minus 2 times 180, since she claimed it's regular, right? So that will be divided by n. This person says that this interior angle is equal to the exterior angle of a pentagon. What's a pentagon? Oh, a pentagon has 5 sides. What's the exterior angle of a pentagon? Oh, well, the exterior angle of a pentagon, the total exterior angle is 360 degrees. Pentagon has 5 sides, so that will give me 360 divided by 5, the angle 72 degrees. So I'm going to take this they claim that the interior angle is equals to 72. So based on here, what's our objective? Okay, number one, we are going to find what is n, and to check whether is it regular or not. Whether is this a regular polygon. So let's try to solve for this equation. There are two different methods, alright, but I should just use one method in this case, method number one. So we just 180n minus 360 equals to 72n. Then I have 180n subtract 72n equals to 360. And I get 108n to be 360. And n to be 360 divided by 108. And that gives me 3 1/3. Okay, so I found n. Is this a regular polygon? How do I decide whether is it a regular polygon? Well, if it's a regular polygon, the number of sides will be an integer. So how do we justify the answer? So since n equals to 3 and 1/3 is not an integer, therefore the n-gon or the polygon GON is not a regular polygon. If it's not a regular polygon, therefore the claim is not true. Okay, have you gotten your answer? Alright, so in this part of the question, this one has no diagram, but it uses the words instead. So read the words and the information part by part, form an equation over here, and then find the value for the number of sides, which is n, and determine whether is it a regular polygon or not. Okay, so with that, I've come to the end of this part of the lesson. I'll see you again for the next lesson. Bye-bye.